I'm sure that everything is going well in your lives. Definitely no reason to be stressed about exams or anything, so, yeah, that's okay, just, it's just food for the giant depression monster on your back that you'll never get rid of for your entire life, so, that's all. So, it's a very Zoomer phrase. Anyway, so let's continue on talking about C++, and we'll see how far we get. Any questions about anything? I see the class population is beginning to dwindle, which is, I guess, expected. It is that time of the year. Actually, this is still a pretty good showing relative to some classes. Like over the summer, I had a class of in theory, 80 students, and I was lucky if 5 were showing up at the end. But they were also 3-hour classes, and I was recording them. I bring it upon myself a little bit. Anyway, so we were talking about C++. At this point, well, actually, we kind of talked about some of that. So C++ may be considered a superset of C. All C programs are valid C++ programs, but not vice versa. In general, C and C++ share the same basic syntax, although C++ introduces a whole heck of a lot of new operators. Almost all of C's operators and keywords are present in C++ with unchanged semantics. So you can pretty reliably use anything you know about C and translate that more or less directly to C++, which is fortunate. Personally, I think that any C++ course should begin with a C course. The memory model is largely the same, as are functions, scoping, and variables. You have to learn a few new rules to handle object-oriented and the scoping rules about that, but in general, it should be reasonably cogent with what you've seen in other object-oriented languages. When they did Python with you guys, did they do much object-oriented? A little bit? Did they get into private versus public? A little bit? Yeah.
Around the end.
So nobody was paying attention and it wasn't on the exam?
Well, lectures were hard to understand.
Oh. Okay. I'll try to do better than that, but I have no idea what I'm trying to do better than. So, this, part of the point of this is also to sort of reinforce OO for you guys, because I know with me, when I was in first year, object-oriented was basically not covered much at all. And then, by the time I got to 3rd and 4th year, I was expected to have been trained in it just like all of the software engineers, because that's how mechatronics works. But, so I'm trying to do you a bit of kindness. But anyway, the main differences. C++ supports object-oriented programming via the inclusion of classes. Additionally, exception handling is also a supported feature. However, C++ also does signal handling, so it does both. So, here is C++ Hello World. Let's compare the following C++ program to our knowledge from C. So, include IO stream. Notice, first of all, that we're importing a different library. Notice the shocking and unsettling lack of a .h file extension. Int main, as you would expect. std : cout, that's strange. Less than, hello world, in the way you would expect, semicolon. Note the lack of printf, right? You may have noticed this. Printf is kind of clunky. C++ decides to do printing to standard output in a different way. So, Notice that we are no longer using stdio.h to access std out using printf. Instead, we are using iostream. Also, we have two new operators to worry about right off the bat. So number one, scope resolution operator, and stream insertion operator. One of the big things in C++ is namespace, which we'll get to. In order to compile C++ programs with GCC, you have to use G++. Technically, you can use GCC with a bunch of options enabled, but G++ is just GCC with all of the options that enable C++ compiling enabled already, so you might as well just use G++, it's much simpler. Right? Question?
Is it possible to run like C on G++? Is it like exactly GCC with extra stuff?
Well, because all C programs, all C programs are C++ programs. If you take a C program and feed it into G++, in theory it'll compile it just as if it were a C program. But the reverse is not true.
Is there any like extension stuff like -lm for example or G++, or is it like
I don't know about -lm with C++. My intuition is telling me that you probably still have to link the math library. If anybody knows that, please feel free to chime in. So, invoking GCC can work if you set certain compiler flags, blah, 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 but the GCC man page recommends using G++ instead. If the man page recommends it, then you should take that to heart. G++ usage is precisely the same as with C, just we use .cpp files instead of .c files. So the file extension for C++ source code files is .cpp. Once your code is compiled, you may also execute it in the same manner that you are currently accustomed to. A C++ mode or plugin for your favorite IDE should be simple enough to find if they aren't already pre-installed. Once again, be wary of which compiler you're linking to by default. As with C, in C++, GCC is considered the good one, the standard compiler, at least for this course, and I highly, highly, highly recommend having GCC running in your back end and not whatever the frick Windows is doing. Okay? Cool. Does the constant tirade of hatred against Windows get tiresome?
No.
No? Is it, I try to do it a little bit for comic effect, hopefully. Anyway. It really is, like, honestly terrible, but, so it goes. So, whereas in C, you write output to your system's standard output file, in C++, you send characters to the standard output stream. So we're not sending things directly to standard output. They do end up there eventually, but C++ introduces a kind of a middleman layer between your program and standard output. The stream itself is called cout and is located within the standard namespace. This is why the scope resolution operator is necessary to find it. So, in C++, you have functions grouped by namespace, right? Or functions and objects are grouped by namespace. So, in order to access a function or an object or a class or anything of that nature inside of a particular namespace, you must specify the namespace that it's located inside of, scope resolution operator, and then the thing you're looking for. Make sense? It functions somewhat like dot syntax, except it's got 4 dots instead of just 1. The stream insertion operator is used to put elements into the stream. You can chain together multiple insertions on one line, and there's also a stream extraction operator, which coincidentally enough, is just arrows in the other direction for taking inputs from streams. So, slightly more complicated example. You, hopefully you remember what a pain in the butt it is to read data using scanf in C, right? So, we have main, we declare int x and int y. We enter a number into the output stream. We then capture the input stream Cin and store it in x. Right? We don't have to worry about the you know, what you call it, the format string. The format string is absent here. We don't have to worry about providing the address of x instead of x. We don't have to worry about that either. It's more convenient. Then we have another one, enter another slightly more complicated number. We take Cin from that, and then the sum of your numbers is, we put that into the stream, and then separately we also stream in x plus y, and then we put the end of the stream in there. So, let me see if I've got these, programs. We can run them. Yeah, there we go. So, here is our hello world. G++, hello.cpp, out hello. You can see hello has been created. Execute hello. And there we go. This example has been made slightly more complicated to indicate how one inserts numerical information into the output stream, which is something that the other one is doing as well. Does that make sense? Hello world? Cool? Let's take a look at interact.cpp. Oh, that's interact. Jeez. There we go. So, here we have exactly the program from the slides, except the declaration of int of x and y has been spread out through the program somewhat. G++, interact.cpp, out interact, compiles without issue, interact, enter a number, 8, enter another slightly more complicated number, 64, the sum of your numbers is 72. Make sense? One might argue that this is more readable than C. Generally speaking, C++ is considered a difficult language to work with. However, C might be more difficult depending on your perspective on things. Make sense? At least for this easy stuff. Things do get more complicated once we start talking about classes. So, good. Similarly to standard cout for sending outputs to the console, we have standard cin for taking inputs from the console. To extract data from the input stream, we use the greater than operator and specify the destination variable. In C, we had to manually specify a format using formatting tags. Not so with C++. The data is automatically formatted to the data type of the container variable. What? Standard, oh, I'm missing a colon there. End-L does two things. Number one, inserts a new line character. Number two, flushes or prints the output buffer. Some systems will wait to accumulate a certain amount of data in the buffer before printing it. So, there is an equivalent C function, f flush. Sometimes if you're having, like if you've put printf statements in your C program but they're not actually printing, sometimes putting f flush in the program as well will actually, tell the operating system, no, don't just store it, actually print it, please. But normally it'll do that periodically. Make sense? Good. So, over the next few sections, we're going to talk about various advanced topics in programming and how they are used in C++. Basically, at this point, we're going to assume that any differences between C++ and C syntax, we're going to pick up on the fly here. So, we will talk about overloading, classes, inheritance, polymorphism, and a few other topics besides. So, a few definitions. Number one, let's talk about overloading. So, in computer science, overloading is the idea that a function or operator can be given more than one type signature, and that the function or operator may execute code based on which type signature is used. We are already somewhat familiar with this idea in Python. So, in Python, when you apply the plus operator between two integers, that computes the sum of those two integers. If you put the plus operator between two lists, it computes the concatenation of those two lists. Concatenation and sum are two very different operations, yet we have the same operator enabled. Overloading is what the name for this is overloading. We have overloaded the plus sign to mean different things depending on what the types of the arguments are. Make sense? So far so good? Yes. We can do the same thing in C++. So, for example, if we have three functions, all returning strings, notice that string is now a data type. Recall that in C, you had character arrays. In C++, you actually have strings as a native data type. So, type of int, type of float, and type of bool returns integer, floating point, or boolean. When we have an integer, a float, and a bool, x, y, and z, cout x is a, y is a, and z is a, putting in the result of type of will yield different results. The output is x is an integer, y is a floating point, and z is a boolean. So let me just run that for you. Assuming I have it. Overloading, yes. So, there we go. In the slides, I included basically these function declarations all on one line to save space because it's on a slide, right? So, that business where C doesn't care about new lines or white space or tabs or anything, this carries over to C++. Right? If you expand those out to be sort of the way we normally do functions, we have string type of int x, return, the strings that are appropriate. Make sense? So far so good? Shouldn't be too bad so far, right? So, G++ overloading .cpp out overloading. There we go. No errors. Run overloading. And there we go. Make sense? So, what's happening here, because there are multiple definitions of type of, C++ has an additional step where it examines what the declared data type of the input parameter is and attempts to match that to one of the definitions provided by type of, right? If it if it fails to find a version of type of that's declared with the correct input type, then it'll give you an error saying this function is undefined for these data types, right? Make sense? Good. So, this is as simple as defining multiple defining a function multiple times with different different type signatures. When executing C++, when executing, C++ will execute the selected function that matches the arguments it's called with. This is known as overload resolution. Overloading should be used whenever you have to write multiple versions of a function for multiple argument types. So, a few new things appeared in the previous example, so let's go over them. Let's talk about this line right here, using namespace std, right? What using namespace does, essentially, it allows you to step into the namespace which you are specifying. So because we have begun using namespace std, we no longer have to resolve the scope on cout or endl, right? So we don't have to put std : right? Because we've sort of globally said everything here should be inside of this namespace. Make sense? So far so good? Thumbs up? Good. So, yes, using namespace std. In previous examples, we used the scope resolution operator to access cout, which is located within the std namespace. With this line, we set the whole program inside the std namespace, so we no longer have to prepend std : to our stream objects. According to the GCC documentation, it is a standard requirement that all library components are kept in the std namespace. So that line is, probably going to be, save you a lot of typing. Most of the time you're typing in C++. String and bool. Notice as well that these types, which are not native in C, are native in C++. Incidentally, string is also in the std namespace. So, without std, you would also have to resolve the scope on string. It would be std : string. Make sense? Cool. So, namespaces then. The previous example introduced the concept of namespaces. In C, every function must have a unique name, or else the compiler can't resolve function calls. This makes sense, unless you're doing overloading. Even an overloaded function does not avoid this problem. Two function declarations with the same name may not have identical type signatures. Even if they have different return types, two functions with identical arguments frustrate overload resolution. So, for the purposes of overloading, you can't have two functions that have the same input types, right? Even if they have different output types. Because the decision that C++ has to make is, which version should I pick based on the input types? If there are multiple functions with the same input type, then trying to resolve overloading, will result in more than one function being a valid function to be executed, which is not good. That's an error. Make sense? Cool. Functions do not conflict with each other if they are put in different namespaces. So, we have a new example revolving around namespaces. We have alpha and beta. We have inside of alpha a foo function, and as well one inside of beta. The alpha version returns, yup, that's a function. The beta version returns, this might also be a function. So, using namespace alpha sets this as, it puts all of the stuff inside of here into the current scope. So the default version of foo will be this one. However, beta's version of foo will still be accessible using scope resolution. Make sense? Hopefully, a little bit. So, there we go. So let's just, oh, comment characters are the same, in case you were wondering. So, note that if I comment out namespace alpha, I hit a compiler error. Foo was not declared in this scope. So foo does not exist in the global namespace. It does exist inside of both alpha and beta, but not in the global namespace. And it also makes some suggestions about places that you could find similarly named functions. So we resolve this by saying alpha. This resolves our compiler error. When we run the function, when we run the program, we get, yup, that's a function. This might also be a function. So there we go. Now, if we re-enable using namespace alpha, it still works. However, if we enable both namespace alpha and beta, using, because I've specified, this resolves the namespace conflict. But if I remove those, then we got a problem. Call of overloaded foo is ambiguous. So because foo takes the same input, that is to say no input, it cannot resolve which instance of foo is meant. Make sense? So far so good? Any questions? Yes?
What would happen if you commented out the STD on lines 4 and 10?
Sorry, on which line?
4 and 10.
Oh, then this would no longer be a function. Yeah, that's necessary to designate that as a function. So, like you could set a constant, you know? You could say something like, string, or sorry, std string bar is equal to, this is a string. And then you could, you could insert bar. But because that's a function, if you're, like that's the std string is the return type of the function. Yeah, question?
If you were to comment out using namespace std, would that cause an error with the beta : foo?
Not with this guy, because this guy is in a namespace that's already inside the global namespace and doesn't need std. But if you were to rub this line out, you would have to put scope resolution operators on Cout, NL, and NL.
Okay.
Yeah.
That makes sense.
Question?
Is it better to like define all the namespaces and use it when you need it, like the instances? So like in this situation, if you have all implemented like beta foo, just like do beta double.
Repeat your question.
So like, is it better to define all the namespaces that we think we might use, and then when it gets specific, we just define that specific variable? So like in this case, it's just like using namespace alpha, beta, and std. And then just like define foo based on what we need.
So you shouldn't really be using namespaces unless you have multiple like things that may come into conflict that you want to separate, right? So this is kind of like this is a very C++ like point, like a very C++ thing to say, but namespaces themselves are probably not something that you will use a whole heck of a lot when you're actually doing your programming practice. You're much more likely to be using classes in these types of ways. Like, you're probably not going to be working on anything complicated enough that you have to split and designate individual namespaces unless a professor has set a question specifically to exercise that, right? This is really like something that enables very large program development, right? But in order to understand how C++ like uses the, like to really understand what the colon means, this example is necessary, right? So this is necessary for your understanding to use C++, but the idea that you would be making your own namespace, like the idea that you would write a C++ program and the first thing you would do would be to like lay out 3 namespaces, probably not. Make sense?
Makes sense.
Yeah. Any other questions? Yes.
So, if you have the same function with different data types, you can basically overload it.
Yeah. And you don't need to separate them by namespace either. It's only when you have 2 functions that have the same input type and you want 2 different versions.
Okay, if
Yeah.
I have a function with like the same input type or like a different number of inputs.
Oh, yeah, that counts as different input type.
Okay.
Input type is you can kind of think of it as a tuple of all of the input types of all of the arguments. Yeah, make sense?
Yeah.
Any other questions? Cool. These are good questions. Yeah, it's very much in the category, you need this knowledge to be able to really program in C++, but like, yeah. So, good. We add things to a namespace by declaring them inside a namespace block. You can also have nested namespaces. Ordinarily, things inside a namespace must be accessed using absolute addressing, i.e. std : cout. The using namespace statement loads everything into the specified namespace, into the top level, meaning you no longer have to provide the full path. Multiple namespaces may be loaded with using at a time, so long as there are no namespace conflicts between the loaded namespaces. Well, we actually just tried that, and it turns out that it's only a conflict if you actually use them. So figure that one out, you know? So, classes in Python, classes in C++. It can scarcely be denied that the supreme goal of all theory is to make the irreducible basic elements as simple and as few as possible without having to surrender the adequate representation of a single datum of experience. That is Albert Einstein telling us what modularity is. So, let's talk about classes. Class on classes. So, I wrote these slides before I had like fully developed my hatred of Python, and like I really feel like it's been like brewing for a number of years now. Like it's just like this I've been brewing my hatred for Python in a cask made of hemlock, and for those of you who don't know, hemlock is a poisonous plant that was what Socrates drank in order to kill himself, because it was decreed that he should be killed. Anyway, enough about Socrates. So, whereas a struct allows us to package several variables together into a single entity, a class allows us to package variables and functions. A class can be thought of as a template. It is defined beforehand and describes the way in which a class is used and what it defines. An object is a class which has been instantiated. Objects contain real data and are typically worked on in the main execution of the program. It's the difference between a struct declaration and a variable of the struct type. That's the difference between an object and a class, right? So you declare the structure, that's just the structure declaration. In order to actually have things that use it, you have to declare them inside of main. That is the same distinction between classes and objects. Make sense? Hopefully you guys have seen this a little bit before. After this, you will hopefully come to appreciate how terribly classes are implemented in Python. I think we have more than thoroughly expounded that particular subject so far. So, basic class declaration. We declare class point. This might seem reasonably similar to some Euclidean geometry. Basically, we're going to do classes to do a slight amount of geometry here. So, class point, we have public and private tags inside of class point. We have double x and y, which are designated public, and we have double z, which is designated private. Inside of main, we declare a point foo. We say foo.x is 3, foo.y is 7, and then we print the values accessing .syntax. So far, not terribly different from Python. The only difference, of course, is the public and the private tag. So, declaring a C++ class is highly similar to declaring a struct in C. We start with the class keyword and specify the name of the class. Class point, open curly brace. The contents of the class are delimited by curly braces, and the whole thing is semicolon terminated. Semicolons. Classes are generally composed of data members, aka fields, parameters, or attributes, and member functions, aka methods. You may also hear me refer to data members as member variables. This is the nomenclature that C++ prefers, and frankly I have yet to see nomenclature I prefer to it. So member functions are functions inside of classes. Member variables are variables inside of classes. Very simple, very straightforward. Any Java guys in here? Guys or gals? Yeah, so member functions are methods. Yeah, which you probably already knew. Anyway, the above class, which will be running will be a running example, is a class for a point in Euclidean space. At present, it has two public members, x and y, and a private member, z. These members are accessed in main like regular variables, but through the declared instance of point. Make sense? So far, not too different from what you saw in Python, I assume. Yeah, good. So, So what distinguishes public from private? Public stuff is universally accessible to everything in a C++ program. It is externally accessible. Members may be read from, written to, and executed from without the class. Private members have access restricted to members of the same class. Members may not be read from, written to, or executed except by other members of the class, public or private. So, members of the same class, right? So when you instantiate this as an object, the only thing that can operate on private member variables are member functions in the same object. Yes?
Just to be clear, it's not different different objects that are the same class.
Right.
You can't.
Yeah.
Because the slide says it's just the same class, but it's the same object.
Yes. If you have two objects instantiated from the same class, they do not have access to each other's private members. Yeah. Remember the principle of least privilege. Give no more access than what is functionally required. My favorite analogy for private versus public in object-oriented is a fast food restaurant, right? So in a fast food restaurant, you have a building which is designated into two areas. You have the public portion of the building and you have the private portion of the building. The public portion of the building has the seating area where people eat food, right, and discuss their lives and do other assorted things. You have the private area, which is the kitchen where the food is prepared, and those functions necessary for the maintaining of the operation are performed. This is where the manager's office is, for instance, if the manager has an office. The interface between the public portion and the private portion are the public member variables, right? So public member variables are the cash register and whoever is standing at the cash register taking orders, right? This does not exclude the possibility of functions which occur only in the private part of the restaurant, or functions that happen only in the public area of the restaurant. For example, if the restaurant is one that has a soda drink machine in the public area of the restaurant, then customers getting themselves their own sodas is a public function. If, in the private area, cleaning out the fryer is a private function. At no point does any public person even need to know that it's happening, right? Yet, still necessary for the operation and maintenance of the restaurant. At least I hope that they clean those regularly. They're supposed to, but anyway. So, modularization and information hiding. So the question might be, why not just make everything public? Why bother with privacy at all, right? Certainly it seems like we don't get much privacy these days. Snark, snark. Jokes about the internet and Google, etc., etc. Anyway, private members seem like a pain. Why bother with all that rot? The ability to make members private allows you to enforce data policies, i.e., you can prevent people from accessing data in ways that it wasn't intended to be accessed. And that actually works this time because it's not bloody Python. By making parts of your code inaccessible, your software will present a stable interface to anybody who wishes to use it. This means that design decisions, or parts which are likely to change, do not impact the manner in which your program is used. This is known as information hiding. If you if you end up taking 3K04, and I don't know if Dr. Wassing still teaches that course, but information hiding is a major theme, shall we say. So, essentially, Modularization is the only thing which enables large software programs to exist, right? If everything was written in C, things would not be very large because C is difficult to work with and modularizes poorly because it doesn't have classes, as I'm sure all of you have figured out. The idea with a class is that you want to present someone else with some code where all they have to do is call some functions, provide the data as expected, and it just works. They don't have to worry about anything past that. They don't have to worry about how that data is being internally represented, because that might be a decision, right? They don't have to worry about the algorithmic efficiency of the functions that are in the library. That might also be something, you know, that is modified over time to make things more efficient. For example, let's say you're playing a video game, and perhaps a little bit like the recent Pokemon games that were released, the game is a bit jank and just really doesn't run very well, and it's really inexcusable because how much money does Pokemon make? There are two types of modification you can make, right? You can hire some actual goddamn software engineers at Game Freak who actually know a little bit about algorithms to be able to optimize that bad boy, because there are lots of games that are much more complicated that don't run like ass like that thing does. You can hire people, fix the algorithms on the back end. Nobody needs to know what you actually did, right? The players themselves, you don't want them getting involved in the algorithms running in the back end. That's just, you know, the 8-year-olds will just cry, and B, the 20 and 30-year-olds will just find exploits. So you want to keep them away from that stuff, right? But like, it's kind of like you download the update, it patches the code, you turn the game on again, and like the interface has not changed, but everything runs better and more smoothly, right? That's what you want to go for, you know? You don't want like, you don't want to fix the fact that like for some goddamn reason rendering plants is too much to expect for a Pokemon game. You don't want that, fixing that problem to like introduce a problem where like anytime you put a Pokemon in the 6th slot in your party, like you lose all of your 15th item in your inventory or something like that. You want to avoid problems like that, right? Modularization, yes?
So is the concept of information hiding kind of similar to encapsulation, or?
Yes, it's very similar. The question is, what are you encapsulating, right? Like putting things inside of a class is encapsulation, right? You don't necessarily need to introduce any private members to have encapsulated, right? Once you start being intelligent about what you're hiding and what you're not hiding, that's information hiding. So information hiding is a subset of encapsulation. That's the one you want to shoot for.
Thank you.
Cool. Any other questions? Yeah, okay. Take it easy, folks.